In this video, we're going to discuss the three variants of gradient descent. To start with, why do we even have three variants? Well, that is because you can write the gradient of the objective as a sum over n gradients. Each object in the training set contributes a gradient vector, which are summed together to get the total gradient. There are different variants because we can decide not to use all objects in each update. In batch gradient descent, that we have seen before, we use all objects in each iteration. So we first compute the whole sum and then we do our update. The opposite extreme is called stochastic gradient descent, which is often abbreviated as SGD. For SGD, we only use a single randomly selected training object for our update. The third option is called mini batch gradient descent. For this variant, we take k randomly selected objects of the training set, compute their gradients, sum them together and use the resulting vector for the update. Now, how do these compare? One advantage of batch gradient descent is that you can do all gradient calculations in parallel. Therefore, this method is more efficient. The downside is that your whole dataset needs to fit into memory, and this might not always be possible. Why would you use SGD or mini batch gradient descent instead of batch gradient descent? Please pause the video to think about the answer. Okay, welcome back. The answer is that it all has to do with memory. With SGD or mini batch, we only need to fit one or k objects into memory. So that is why people often use stochastic or mini batch gradient descent in practice. How to decide between these two? Well, since SGD only uses a single object, some updates can be very noisy or wrong. Imagine the object that you are using is an outlier, then your whole update might be in the wrong direction. For mini batch, we first average the gradient over k objects. Because of this, we average out some noise, so our update is more accurate. There's another downside with SGD. We compute the gradient each time, one object at a time. Therefore, we cannot do this computation in parallel. So this is much less efficient than batch gradient descent. For mini batch, we need k gradients at each time. Therefore, this computation can be parallelized. Thus, mini batch is more efficient than SGD. However, batch gradient descent is most efficient, since it can compute all gradients of the whole training set in parallel. This picture illustrates the three different variants of gradient descent. The three all start at the location of the star and travel through the landscape of an objective function. One of them is batch, one of them is mini batch, and one of them is SGD. Now my question to you is, which is which? Take a second to think about this and pause the video. Afterward, we discuss the answer. Okay, welcome back. Let us discuss the answer. The blue line is most noisy. Therefore, this is SGD. Since it uses one object at a time, many steps are noisy and wrong. The orange line is a little bit less noisy, therefore this is mini batch. It takes an average over several objects and therefore its steps are less noisy. The green line has the least noise and therefore this is batch gradient descent. Okay, let's summarize this video. We discussed three variants of gradient descent: batch, SGD and mini batch gradient descent. We compared the three methods in terms of accuracy of their updates and how efficient they are due to parallel computations. Batch uses the complete training dataset and therefore has the most accurate updates and is most efficient. Use batch only if you have enough memory. Otherwise, we can use SGD or mini batch. Mini batch is preferred because it is more efficient and has more accurate updates compared to SGD.